Look up into the quiet emptiness of the night sky, a vast and silent theater of distant, glittering lights. Every star you see is a sun, a colossal furnace burning across an ocean of time that is almost impossible to comprehend. Our minds have learned to measure this time, to chart the slow waltz of galaxies and the steady expansion of space itself. We trace the story of the cosmos backward, through billions of years, past the birth of our own sun and our own world. The further back we look, the stranger the universe becomes, a place of searing heat and unimaginable density, unfamiliar and primordial. We can follow this thread of cosmic history all the way back to a single moment, a point of origin for everything we know. This moment, which we call the Big Bang, represents a kind of wall, a boundary beyond which our current physics cannot see. It is the first page of the cosmic story, the beginning of time, space, and all the matter that fills our universe. But the human mind, in its quiet and persistent curiosity, cannot help but ask the most profound question of all. If this was the beginning of everything, then what was here, in the unimaginable state that existed before the beginning? We are accustomed to cause and effect, to a chain of events where one thing logically follows another through the river of time. The idea of a moment before which there was no time at all feels like a paradox, a concept that our language struggles to contain. To even begin this journey, we must release our familiar notions of before and after, of empty space and the passage of moments. We must venture into a realm of pure potential, a place where the laws of physics themselves had not yet been written. Imagine not a dark and empty void, for even a void is a something, quote, a stage waiting for actors to appear. We must instead try to contemplate a state of true nothingness, an absence so complete that it lacks even the dimension of space. This is the starting point for our cosmic philosophy, the ultimate mystery that has haunted thinkers for millennia, from poets to physicists. The question is not about an empty room before the furniture arrived, but about the existence of the room itself. Our telescopes and instruments can show us the echoes of the Big Bang, the faint afterglow of creation from 13.8 billion years ago. But they cannot pierce the veil of that initial singularity, that infinitesimal point from which all of reality bloomed into being. So we must turn inward, to the tools of theoretical physics and contemplative thought, to explore what might lie beyond that boundary. Let your mind settle, and allow the weight of this question to anchor you in a state of profound and meditative calm. We are not seeking simple answers here, for there are none to be found in the conventional sense of knowing. Instead, we are embarking on an atmospheric journey to the very edge of understanding, to the precipice of existence itself. The first concept we encounter is that the question itself might be flawed, based on a human-centric view of time. We perceive time as a straight line, an arrow flying from a past we remember towards a future we anticipate. But what if time is not so fundamental? What if it is an emergent property of the universe, just like temperature or pressure? To ask what came before the Big Bang would be like asking what is north of the North Pole on the surface of the Earth. The question seems to make sense in our language, but when you examine the geometry of the system, it becomes meaningless. At the North Pole, the direction we call north ceases to exist. All directions simply point south, away from that point. Perhaps the Big Bang is the North Pole of time, the absolute origin point where the concept of before simply dissolves. Time, in this view, did not exist within some pre-existing void. Time itself began with the universe's expansion. This is the no-boundary proposal, a mind-bending idea that suggests the universe is a self-contained entity without a creator or a prior cause. It simply is, a complete and finite system in imaginary time, which we perceive as an explosive beginning in real time. Let this idea wash over you, the concept of a universe with no edge, no beginning, and no end in the ultimate sense. But this is only one path into the mystery, one possible interpretation of the mathematics that describe our cosmic home. Another path leads us into the bizarre and unpredictable world of quantum mechanics, the physics of the very small. On the quantum level, the idea of a true, stable nothingness is an impossibility, a state forbidden by the laws of nature. Even the most perfect vacuum is not empty. It is a seething, effervescent soup of energy and fleeting virtual particles. Particles of matter and antimatter can spontaneously pop into existence from nothing, exist for an infinitesimal moment, and then annihilate each other. This quantum foam is the fundamental ground state of reality, a realm of pure potential from which something can always arise. What if, before the Big Bang, this quantum foam was all that existed, a timeless, spaceless ocean of probabilistic energy? A random fluctuation, a quantum leap of unimaginable scale, could have been the spark that inflated into our entire cosmos. Our universe in this view is not a unique creation, but a statistical inevitability, a chance occurrence in an eternal quantum dance. There was no single moment of creation, but rather a transition from a state of timeless potential to a state of unfolding space-time. Both of these ideas, the self-contained universe and the quantum fluctuation, challenge our deepest intuitions about reality. They replace a simple beginning with a more complex and abstract origin that defies easy visualization or simple narrative. And yet, there are still other theories, other doorways into the great mystery of what preceded our known existence. Some physicists speculate that our universe is not the first, but merely the latest in an infinite series of cosmic cycles. This is the idea of the Great Bounce, a universe that expands, collapses, and is reborn from its own ashes endlessly. To truly appreciate the scale of this cyclical hypothesis, we must first visualize the end of our own universe, a future so distant it borders on the fantastic. Imagine trillions upon trillions of years passing. The last stars have long since extinguished their fires, leaving behind only the cold, silent husks of black dwarfs, neutron stars, and isolated black holes. The galaxies themselves will have dissolved, their stellar remnants scattered across a vast and darkening expanse. In this era of deep cold, even the protons that form the basis of all matter may eventually decay, leaving behind a thin, featureless soup of radiation and elementary particles. All structure, all information, all memory of what came before will be erased. The universe will have reached a state of maximum entropy, a placid and uniform sea of near-nothingness stretched across unimaginable distances. This is the heat death, the seemingly final chapter. But in the theory of a cyclical universe, this is not an end. It is a metamorphosis. Proponents of models like conformal cyclic cosmology, proposed by Roger Penrose, suggest that in this state of near-infinite expansion and near-zero density, the universe loses its sense of scale. The physics governing a vast, cold, empty universe becomes mathematically equivalent to the physics of a hot, dense, tiny universe just before a Big Bang. The end of one cosmic eon seamlessly becomes the beginning of the next. The before in this scenario is not a state of nothingness, but rather the ghost of a previous universe, its final, expanded state, compressed into the initial singularity of our own. We are living in the aftermath of a cosmos that lived and died, its fundamental particles and energy repurposed to create the very stars and galaxies we observe today. An alternative cyclic model, known as the Big Bounce, imagines a more violent and dramatic rebirth. Instead of expanding forever, this theory posits that at some point in the distant future, the mysterious force we call dark energy might weaken or reverse, allowing gravity to once again become the dominant force on a cosmic scale. The universe's expansion would slow, halt, and then reverse into a period of cosmic contraction, the Big Crunch. Galaxies would rush back towards each other, merging into a single supergalaxy. The temperature and density of the cosmos would skyrocket, reversing the process of the Big Bang. Stars would be torn apart, atoms stripped of their electrons, and even atomic nuclei would be ripped asunder, until everything that ever was is compressed back into an infinitesimally small, infinitely hot point, a quantum singularity. According to the Big Bounce hypothesis, this singularity is not a point of annihilation, but a point of transition. As the universe is crushed down to the Planck scale, the smallest possible scale in physics, our classical understanding of gravity breaks down and quantum gravitational effects take over. These quantum forces would provide a repulsive pressure, a kind of cosmic spring that resists the ultimate collapse. Instead of ending in a final singularity, the universe would bounce, converting the immense energy of its collapse into the explosive expansion of a new Big Bang. In this breathtaking vision, the state before our universe was the contracting phase of a prior cosmos, a cycle of cosmic inhalation and exhalation that may have been repeating for eternity, with no true beginning and no ultimate end. Let us now leave the realm of cosmic cycles and venture into an even more expansive and bewildering possibility, the multiverse. This idea stems from a theory called eternal inflation, which attempts to explain the astonishingly rapid expansion of the universe in the first fraction of a second after the Big Bang. The theory suggests that this inflationary process, driven by a quantum field called the inflaton, might not have been a one-time event. Instead, it could be a continuous, eternal process happening throughout the cosmos. While inflation stopped in our region of space, allowing our universe to form and cool, it continues unabated in other, more distant regions. This cosmic landscape would be like a perpetually boiling pot of water, where our observable universe is just one tiny bubble that has momentarily cooled. In this eternal inflationary model, new bubble universes are constantly being born from the ever-expanding quantum foam of the parent spacetime. Each bubble would nucleate from a quantum fluctuation, rapidly expanding to become its own self-contained cosmos, with no ability to communicate with the others. The Big Bang of our universe, then, was not the beginning, but merely a beginning, the moment our particular bubble branched off from the eternally inflating multiverse. What came before our Big Bang was simply the superspatially vast, timeless, and chaotic inflationary sea. We are a single-ordered island in an infinite ocean of cosmic creation, and an infinite number of other universes, other islands, are forming and evolving at every moment, completely beyond our reach and perception. This multiverse concept takes on an even stranger dimension when we consider that the laws of physics might not be universal. As each new bubble universe is born, the fundamental constants of nature, such as the strength of gravity, the mass of the electron, or the speed of light, could settle into completely different, random values. Most of these universes would be sterile and inhospitable. A slightly stronger nuclear force might cause all hydrogen to fuse into helium moments after their Big Bang, preventing the formation of stars. A slightly weaker force of gravity might prevent matter from clumping together to form galaxies. Our universe, with its exquisitely fine-tuned parameters that allow for complexity, stars, planets, and life, would be an incredibly rare and fortunate outcome in a vast cosmic lottery of stillborn realities. The final intellectual path we will explore tonight is perhaps the most abstract, originating from the frontiers of theoretical physics known as M-theory, a candidate for the, quote, theory of everything. M-theory proposes that our universe is not the whole of reality, but is instead a four-dimensional membrane, or brain, floating within a much larger, higher-dimensional space called the bulk. Imagine a single sheet of paper existing in our familiar three-dimensional room. The paper is the brain, and the room is the bulk. M-theory suggests there could be other brains, other parallel universes, floating just millimeters away from our own in these extra hidden dimensions, completely invisible to us because we, and all the forces of nature except gravity, are confined to our own brain. Within this framework, a new and dramatic origin story for our universe emerges. The Big Bang might not have been a beginning from nothing, but rather the result of a cataclysmic collision between two of these parallel brain worlds in the higher dimensional bulk. The kinetic energy from this cosmic impact would have been converted into the searing heat and matter of our universe, igniting the process of expansion that we observe today. The state before the Big Bang was a colder, more placid existence of two parallel universes drifting silently through the bulk on an inevitable collision course. This ekpyrotic model, from the Greek word for conflagration, presents a universe born not from a singularity, but from a spectacular and generative clash in a higher dimensional reality that fundamentally underpins our own. The Hartle-Hawking no-boundary proposal presents one of the most elegant and philosophically challenging solutions to the question of a beginning. It uses a mathematical tool called imaginary time, which behaves like another dimension of space rather than the forward-marching time we experience. In this formulation, the universe's origin looks less like a sharp point or singularity, and more like the smooth, curved surface of a sphere, similar to the South Pole on Earth. Just as the South Pole is a point on Earth's surface that is not preceded by any other point, it is simply where the lines of longitude begin. The Big Bang in imaginary time is a point where the universe begins without being preceded by anything. Time, as we know it, crystallizes out of this timeless, spaceless geometry as the universe expands. This concept dissolves the very idea of a before. It suggests that searching for a cause that precedes the Big Bang is a logical error born from our limited classical intuition. The universe, according to this proposal, didn't need a creator or a prior state to kick it into existence. It is a self-contained, closed system whose existence is fully explained by the laws of quantum gravity. It is a story that has a first chapter but was not written in a pre-existing book. The book itself came into being with the first word. Meditating on this idea allows the mind to release the anxiety of an infinite regress of causes, replacing it with the calm, profound contemplation of a universe that is mathematically and logically complete in and of itself. Let us return to the quantum foam, that seething cauldron of virtual particles that represents the ground state of reality. The Heisenberg uncertainty principle dictates that one can never know both the precise energy and the lifetime of a quantum system. This allows for tiny energy loans from the vacuum, creating particle-antiparticle pairs that exist for fleeting moments. Physicists like Alan Guth wondered if the entire universe might be the ultimate free lunch, a massive energy fluctuation with a net energy of precisely zero. The positive energy locked away in matter and radiation could be perfectly balanced by the negative energy of gravity. If the total energy of the universe is zero, then no law of conservation was violated in its creation. It could have appeared from a state of true nothingness without any external cause. This universe from nothing scenario is deeply counterintuitive, yet it is a serious proposition in modern cosmology. The nothing from which it arose is not the simple void of classical thought, but the structured, potential-filled vacuum of quantum field theory. It was a state of pure potential, governed by physical laws that existed in some abstract Platonic sense even before space-time itself. A random quantum tunneling event, similar to how a particle can pass through an impenetrable barrier, could have allowed a tiny bubble of space-time to emerge from this pre-ontological state, which then underwent the hyper-expansion of cosmic inflation. Our vast, complex cosmos could be the result of a probabilistic hiccup in a timeless, spaceless state of non-being, a statistical inevitability in an ocean of infinite potential. The theory of eternal inflation offers a radical perspective on our place in the cosmos. It posits that the inflaton field which drove the universe's initial expansion has different energy levels, creating a landscape of possible physical laws and constants. As the multiverse expands, different regions randomly decay from a high-energy false vacuum state to lower energy states, each decay creating a new bubble universe. This process, known as stochastic inflation, ensures that the multiverse as a whole is always producing new universes, making it truly eternal into the future. Our Big Bang was just one of countless such events. Before our universe, there was the eternally inflating superstructure, a cosmic generator that has been spawning universes for an eternity and will continue to do so, a fractal-like process of creation on the grandest possible scale. This multiverse concept provides a potential explanation for the apparent fine-tuning of our universe's physical constants, a problem known as the anthropic principle. If there are infinite universes, each with different physical laws, it's not surprising that at least one, ours, would happen to have the right conditions for the formation of galaxies, stars, and ultimately, conscious observers to ponder their own existence. We find ourselves in a life-permitting universe for the same reason we find ourselves on a life-permitting planet. All the other possibilities are sterile, and thus there is no one there to observe them. The state before our universe was therefore a chaotic sea of physical potential, and our specific set of laws is not a sign of design but of selection from an infinite palette of possibilities. Delving deeper into M-theory and brain cosmology, we find even more intricate possibilities for our pre-Big Bang era. The higher dimensional bulk in which our universe brain resides is not necessarily empty. It could be populated by other brains, other forms of matter, and energies that we cannot perceive directly. The collision that sparked our universe may not have been a two-brain event, but part of a more complex, recurring cycle. Perhaps brains are continuously created and destroyed in this higher space, or perhaps they oscillate, colliding periodically every trillion years or so. In this vision, the Big Bang is not a singular origin, but a common, repeating event in the cosmic ecosystem of the bulk, as natural and cyclical as the changing of seasons on Earth. The implications of this are staggering. The fundamental building blocks of our reality, our 3 dimensions of space and 1 of time, might be just a slice of a much richer, higher-dimensional existence. The laws of physics we observe might be mere shadows or projections of deeper, more fundamental laws that operate in the bulk. What came before our Big Bang was a state of reality defined by these hidden dimensions, a universe whose geometry and physics are almost beyond our ability to model or imagine. Our quest for cosmic origins forces us to confront the possibility that our entire universe is but a surface phenomenon, a ripple on the waters of a far deeper and more mysterious ocean of existence. Let us contemplate the nature of information in the universe. Some physicists, working on a concept known as the holographic principle, suggest that all the information contained within a volume of space can be described by a theory that lives on the boundary of that region. This is analogous to a hologram, where a 3-dimensional image is encoded on a 2-dimensional surface. Extrapolating this idea to the entire cosmos, it's possible that our 3-dimensional universe is a holographic projection of information stored on a 2-dimensional surface at the farthest reaches of spacetime. What was here before the Big Bang, then, could have been a state of pure, timeless, 2-dimensional information, a cosmic blueprint from which our spatial and temporal reality emerged as a projection. This holographic model connects deeply with the physics of black holes, where the information of everything that falls in is thought to be stored on the 2-dimensional event horizon. If the universe began from a singularity, it shares some properties with a black hole in reverse. Perhaps the pre-Big Bang state was a lower dimensional physics that did not contain gravity or time as we know them. The Big Bang was the moment this information began to project outward, creating the illusion of a third spatial dimension and the emergent property of time's arrow. The reality before was a timeless, flat land of pure code, a cosmic hard drive from which our perceivable universe is continuously being read into existence. Another fascinating, though highly speculative, idea is that our universe was born from the singularity of a black hole in a parent universe. According to general relativity, the singularity inside a black hole is a point of infinite density, where the known laws of physics break down, much like the singularity of the Big Bang. Some theories propose that when matter collapses into a black hole, it might not be crushed out of existence, but could instead rebound and tunnel through to create a new expanding baby universe on the other side. This new universe would be causally disconnected from its parent, existing in its own separate pocket of spacetime. If this fecund universe's theory is correct, then the state before our Big Bang was a star collapsing in a completely different, older cosmos. That universe, in turn, would be filled with black holes, each one a potential seed for a new universe. This creates a kind of cosmic evolution through natural selection. Universes that produce more black holes would have more offspring, and their physical laws would become more common throughout the grander multiverse. It provides a potential mechanism for why our universe has the laws it does. They were inherited from a parent universe that was particularly good at creating black holes, and thus, new universes. It places our existence within a grand, generational cosmic lineage. We must also confront the philosophical limitations of our language and concepts. The very words before, time, and nothing are loaded with assumptions derived from our macroscopic, everyday experience. To ask what happened before time began is a semantic trap. It presumes that time is a container rather than a property of the system itself. Perhaps the pre-cosmic state is something for which we have no words. A state that is neither being nor non-being, a reality that can only be described through pure mathematics. The struggle is not just with the physics, but with the inadequacy of the human mind's conceptual framework to grasp a reality so fundamentally alien to our own. Let your mind rest on this thought, that the ultimate answer may not be a story of cause and effect, but a geometric or mathematical truth. Just as the ratio of a circle's circumference to its diameter is pi, a timeless and fundamental property of Euclidean space, perhaps the existence of our universe is a similar kind of fundamental truth about the nature of reality. It exists because the underlying logic of existence allows it, or even requires it. The state before wasn't a temporal predecessor, but a logical one, a set of mathematical principles or physical laws that contained the blueprint for a universe like ours, as a necessary consequence of their own internal consistency. Consider the concept of symmetry in physics. Many of the fundamental laws of nature are expressions of deep underlying symmetries. At the extremely high energies of the early universe, the fundamental forces, electromagnetism, the weak nuclear force, and the strong nuclear force, are thought to have been unified into a single, symmetrical superforce. Perhaps the state before the Big Bang was one of perfect, absolute symmetry, a state so perfect and featureless that nothing could happen. The Big Bang, then, was a cataclysmic, symmetry-breaking event. A random quantum fluctuation shattered this perfect primordial state, causing the unified force to crystallize into the separate forces we see today, and creating the imperfections, the lumps of matter and energy, that allowed for the formation of structure. In this view, what came before was a state of profound and beautiful simplicity, a universe of perfect equilibrium. Our universe, with all its complexity, chaos, and structure, is the shattered remnant of that initial perfect state. The expansion of the universe and the increase of entropy can be seen as a long, slow journey away from that initial moment of broken symmetry. The ultimate origin of everything we see, from galaxies to life itself, is the consequence of an initial fall from a state of absolute grace and perfection, a cosmological echo of creation myths found in human cultures throughout history. Our existence is owed not to order, but to the breaking of a primordial and absolute order. Each of these theories, from the no-boundary proposal to brain collisions, from the Big Bounce to the eternal multiverse, is a testament to the relentless human drive to understand our origins. They are not proven facts, but magnificent structures of thought, built at the very limits of our mathematical and imaginative capacities. They are the modern creation myths, written in the language of quantum field theory and general relativity. Listening to them is not about choosing the correct one, but about allowing the mind to expand and embrace the sheer scale and strangeness of what might be possible, to become comfortable with profound uncertainty. As we drift through these ideas, notice how they all attempt to solve the same fundamental problem: how to avoid the paradox of a true beginning from an absolute nothing. The cyclical universe posits an infinite past. The multiverse posits an eternal, ongoing creation. The no-boundary proposal dissolves the question itself. The universe from nothing theories redefine nothing as a state of rich quantum potential. All of them are attempts to build a bridge of logic and reason across the chasm of the ultimate mystery, to make the existence of our cosmos seem not like an impossible miracle, but a natural, perhaps even inevitable, outcome of the fundamental nature of reality. Let us consider the role of consciousness in this grand picture. The anthropic principle, in its stronger forms, suggests that the universe is the way it is because it must be observed to exist. This line of thinking, rooted in some interpretations of quantum mechanics, implies a deep connection between mind and reality. Perhaps the state before the Big Bang was a sea of pure potential that only became a concrete, physical universe when the potential for self-aware observers arose within it. This is not to say a human-like mind was necessary, but that the universe's evolution is biased towards outcomes that allow for consciousness to emerge and, in a sense, complete the cosmic circuit by observing it. This is a profoundly unsettling and deeply meditative idea. It suggests that our existence is not an accidental byproduct of a mindless, mechanical universe, but is in some way intrinsically woven into the very fabric of its creation and being. The cosmos gives rise to conscious minds, and those minds, in turn, give reality to the cosmos through the act of observation. The state before the Big Bang would then be an unmanifested reality, a dream in the mind of no one, awaiting the spark of consciousness to call it forth into tangible existence. We are not just inhabitants of the universe, we are the means by which the universe becomes aware of itself. The string theory landscape provides yet another vista into the pre-Big Bang state. String theory requires extra spatial dimensions to be mathematically consistent, and the specific way these tiny, hidden dimensions are curled up and compactified determines the laws of physics in our familiar dimensions. It's estimated there are at least 10 to the power of 500 different ways for these dimensions to be configured, each one creating a different vacuum state with its own unique physics. This creates a landscape of possible universes. Before our Big Bang, reality could have been a different point in this landscape. a universe with different laws, which then tunneled through a quantum event into the configuration that defines our own cosmos. In this model, the Big Bang was not the start of everything, but a moment of phase transition, like water freezing into ice. Our universe is just one of a vast number of possible vacuum states, perhaps one of many temporary valleys in the cosmic landscape. What existed before could have been another universe in another valley that existed for eons before a random quantum fluctuation pushed it over a hill in the landscape, causing it to decay into the state we now inhabit. The origin of our universe was the end of another, not through a violent crunch, but through a fundamental reconfiguration of the geometric fabric of space-time itself, a deep and silent shift in the underlying rules of reality. As our journey through these cosmic philosophies nears its conclusion, let your mind become still. Allow the competing theories and grand narratives to dissolve into a single, profound feeling of awe. The question of what came before the Big Bang is the ultimate koan of physics, a question designed not to be answered, but to push the mind beyond its conventional limits. It is a tool for inducing a state of intellectual humility and wonder. The value lies not in finding a definitive solution, but in the act of contemplation itself, in the serene and expansive state that comes from meditating on the edge of the infinite. We are left with a series of profound possibilities, instead of a single, comforting answer. Perhaps there was a previous universe, locked in an eternal cycle of birth and death. Perhaps there is an infinite multiverse, constantly spawning new realities from an eternal inflationary sea. Perhaps our universe is a hologram, projected from a lower dimensional boundary. Perhaps it is a self-contained object with no beginning in any meaningful sense. Or perhaps it is a single fluctuation in a timeless quantum foam. Each possibility is a universe of thought unto itself, a mental landscape to be explored in the quiet moments of deep reflection. The silence of the cosmos does not provide an answer, but it offers a canvas upon which these beautiful and intricate ideas can be painted. The starlight that travels for billions of years to reach us is a message from the past, a reminder of the immense story of which we are a tiny fleeting part. And the darkness between the stars is a reminder of the ultimate mystery, the profound and perhaps eternal question of why there is something rather than nothing. As you drift now toward sleep, let this question be not a source of anxiety, but a gentle, calming anchor, a final thought that connects your own quiet consciousness to the grandest and most enduring mystery of all. Consider the nature of time itself, not as an external river we float upon, but as an internal psychological construct. Our perception of a before and after is intrinsically linked to memory and entropy. We remember the past, but not the future, because the universe is moving from a state of low entropy to high entropy. In a pre-Big Bang state that lacked entropy's arrow, perhaps time as we understand it simply did not function. There was no before, because the very mechanism that creates the illusion of temporal flow was absent. It was a static, timeless now, a block universe in a state of perfect equilibrium, from which our dynamic, time-flowing universe emerged through a fundamental thermodynamic shift. In this thermodynamic view, the Big Bang wasn't the creation of energy or matter, but the establishment of an initial state of incredibly low entropy. This highly ordered beginning is the ultimate source of all the order and complexity we see today, from the structure of galaxies to the processes of life. The question then shifts from what came before the Big Bang to why did the universe begin in such a remarkably ordered state? The answer to this may lie in the geometry of the initial conditions, a feature that is simply a brute fact of our cosmos, or a clue pointing towards a deeper, underlying principle of cosmic organization that we have yet to discover. Let's re-examine the conformal cyclic cosmology of Penrose in greater detail. This model hinges on the fate of massless particles, like photons, in the far future. As the universe expands and cools, everything will eventually decay into these massless particles. From the perspective of a photon traveling at the speed of light, time does not pass. The entire history of the universe, from its beginning to its end, occurs in a single instant. Therefore, in the distant future when only photons remain, the universe will become conformally equivalent to a Big Bang singularity. The infinitely large and cold future becomes indistinguishable from the infinitely small and hot past, allowing a seamless transition from the end of one eon to the beginning of the next. A beautiful and endlessly repeating cosmic poem. What this implies is that the before state was another universe, one that has a shared history with our own. The largest structures and gravitational waves from the previous eon could leave faint imprints on the cosmic microwave background radiation of our own, the echo of our universe's birth. Scientists are actively searching for these subtle temperature variations, these Hawking points, which would appear as faint circles in the sky. Finding such a signal would be revolutionary, providing the first observational evidence that our universe is not the first, but merely the latest iteration in a potentially infinite cosmic lineage, directly connecting us to a reality that existed before our own time began. The concept of a digital or computational universe offers another lens through which to view the pre-Big Bang state. In this framework, the ultimate reality is not matter or energy, but information. The universe is akin to a giant quantum computer, and the laws of physics are the algorithm it is running. The Big Bang, then, was the moment this cosmic program was initiated. What came before? Perhaps it was a state of pure, unstructured information, a kind of cosmic white noise. Or perhaps it was a simpler program, a bootloader, that set the initial parameters for our own complex simulation. Our reality would be an emergent phenomenon, a virtual world generated by a deeper level of computational processing. This simulation hypothesis, while speculative, forces us to question the fundamental nature of reality itself. If the universe is a computation, then concepts like space and time are not fundamental but are simply elements of the data structure. The before might not be a temporal concept but a logical one, existing in the code that defines our reality. The ultimate origin would lie with the programmer, or the system running the simulation, a question that pushes the mystery back one level further into a realm that may be forever beyond our ability to probe. It transforms the cosmological question into a metaphysical one, blurring the line between physics and philosophy in the most profound way imaginable. Let us contemplate the aesthetic beauty of these theories. The universe of the Big Bounds, with its endless cycles of death and rebirth, has the rhythmic quality of a heartbeat or a breath. The eternal inflationary multiverse, with its infinite bubble universes each containing unique physical laws, evokes the image of a boundless creative foam, endlessly generating new forms and possibilities. The no-boundary universe of Hawking is a model of perfect, self-contained elegance, a complete and finite jewel of spacetime. The brain-world collision is a story of cosmic drama and power on a scale that dwarfs all human mythology. Each theory is not just a scientific model. It is a profound and moving work of the human imagination. These ideas are not meant to be passively received, but actively contemplated. Allow yourself to inhabit each one for a moment. Feel the rhythmic pulse of the cyclical cosmos. Float in the timeless generative sea of the multiverse. Stand at the smooth, edgeless beginning of the no-boundary universe. By doing so, you are participating in one of the oldest human traditions, using the power of thought and imagination to find our place within the grand story of the cosmos. The calm that arises from this practice comes not from having an answer, but from becoming one with the immensity and the elegance of the question itself. The search for a theory of everything is the scientific quest to unite quantum mechanics and general relativity, to find a single mathematical framework that describes all of nature's forces. If such a theory is found, it may hold the ultimate key to understanding the moment of the Big Bang and what came before. Such a theory would describe the universe at the Planck scale, where gravity becomes a quantum force, and our classical notions of space and time dissolve completely. It would not be a theory of things, but a theory of the processes and relationships from which space-time and matter themselves emerge. This ultimate theory might reveal that the Big Bang was not a beginning, but a phase transition, like water turning to steam. The state before could have been a geometric phase, a pre-space-time reality, where the universe existed as a complex web of quantum information, or a set of pure mathematical relationships. The Big Bang was the moment this abstract pre-geometric state crystallized into the familiar fabric of space-time we inhabit. In this view, the universe didn't emerge in space, but rather space emerged from the universe. What existed before was a deeper level of reality, one without location, distance, or duration, a realm of pure potential governed by the ultimate laws of quantum gravity. Think of the conservation of energy, a fundamental principle stating that energy cannot be created or destroyed. For the universe to spring from nothing, its total energy must be zero. The positive energy of all the matter and radiation in the cosmos is immense, but the energy of the gravitational field is negative. Every star, every galaxy is a source of positive energy, but it is also a source of a negative gravitational potential well. It is entirely possible, and indeed predicted by inflationary theory, that these two values perfectly cancel each other out, resulting in a universe with a net energy of exactly zero. Our cosmos is the ultimate example of borrowing on a cosmic scale. If the universe's total energy is zero, then it could have come into existence as a random quantum fluctuation without violating any conservation laws. This makes the universe from nothing a scientifically plausible hypothesis. The nothing here is the quantum vacuum, a state devoid of matter but still subject to the laws of physics. It paints a picture of a pre-Big Bang state that was not an empty void, but a latent realm of physical law, waiting for a probabilistic event to bring forth a zero-energy universe like ours. The sheer existence of our vast cosmos could be a testament not to an act of creation, but to a subtle and perfect balance between the positive energy of being and the negative energy of gravitation. Ultimately, all these paths of inquiry lead us to the boundary where science and philosophy merge. Science can build models that push ever closer to the moment of origin, describing the state of the universe a fraction of a second after the Big Bang with incredible precision. But the question of why there are physical laws at all, or why there is a quantum vacuum with the potential to create universes, may be a question that lies beyond the reach of empirical testing. This is the realm of metaphysics, the study of the fundamental nature of being and reality. It is a space for quiet, open-ended contemplation rather than definitive proof. As you rest in this meditative space, acknowledge the profound peace that can be found in accepting this limit. The human mind is a remarkable instrument, capable of comprehending the cosmos on a scale that would have been unimaginable just a few centuries ago. But like any instrument, it has its limits. The ultimate origin may be one such limit, a mystery so fundamental that it serves as a permanent anchor for our sense of wonder. To be alive and conscious in a universe that contains such a profound and beautiful question is a gift. The goal is not to eliminate the mystery, but to learn to live with it, to appreciate its depth, and to allow it to inform our perspective on our own fleeting existence. The light from the most distant galaxies we can observe has been traveling for over 13 billion years. When we look at these galaxies, we are seeing the universe as it was in its infancy, a snapshot of a time when the first stars and structures were just beginning to form. This deep field view is the closest we can get to physically observing the past. Every photon carries a story, a fragment of the cosmic narrative. But this light also defines a horizon, a boundary beyond which we cannot see, simply because the light from more distant objects has not had enough time to reach us since the beginning of the universe. This cosmic horizon is a powerful metaphor for our intellectual journey. We have pushed our understanding back to the cosmic microwave background, the afterglow of the Big Bang itself. Beyond that lies the opaque wall of the primordial plasma. And beyond that conceptual wall lies the singularity, the moment of creation. Our theories are like telescopes of the mind, attempts to see beyond this wall. Whether the landscape beyond is an endless cycle, an infinite multiverse, or the smooth, edgeless shore of a no-boundary state, the act of looking changes us. It connects our inner world of thought with the silent, majestic outer world of the cosmos, leaving us in a state of deep, intellectual awe and profound, meditative calm. This concept dissolves the very idea of a before. It suggests that searching for a cause that precedes the Big Bang is a logical error born from our limited classical intuition. The universe, according to this proposal, didn't need a creator or a prior state to kick it into existence. It is a self-contained, closed system, whose existence is fully explained by the laws of quantum gravity. It is a story that has a first chapter, but was not written in a pre-existing book. The book itself came into being with the first word. Meditating on this idea allows the mind to release the anxiety of an infinite regress of causes, replacing it with the calm, profound contemplation of a universe that is mathematically and logically complete in and of itself. This is a profoundly unsettling and deeply meditative idea. It suggests that our existence is not an accidental byproduct of a mindless, mechanical universe, but is in some way intrinsically woven into the very fabric of its creation and being. The cosmos gives rise to conscious minds, and those minds, in turn, give reality to the cosmos through the act of observation. The state before the Big Bang would then be an unmanifested reality, a dream in the mind of no one, awaiting the spark of consciousness to call it forth into tangible existence. We are not just inhabitants of the universe. We are the means by which the universe becomes aware of itself. In this model, the Big Bang was not the start of everything, but a moment of phase transition, like water freezing into ice. Our universe is just one of a vast number of possible vacuum states, perhaps one of many temporary valleys in the cosmic landscape. What existed before could have been another universe, in another valley, that existed for eons before a random quantum fluctuation pushed it over a hill in the landscape, causing it to decay into the state we now inhabit. The origin of our universe was the end of another, not through a violent crunch, but through a fundamental reconfiguration of the geometric fabric of space-time itself, a deep and silent shift in the underlying rules of reality. In this thermodynamic view, the Big Bang wasn't the creation of energy or matter, but the establishment of an initial state of incredibly low entropy. This highly ordered beginning is the ultimate source of all the order and complexity we see today, from the structure of galaxies to the processes of life. The question then shifts from what came before the Big Bang to why did the universe begin in such a remarkably ordered state? The answer to this may lie in the geometry of the initial conditions, a feature that is simply a brute fact of our cosmos, or a clue pointing towards a deeper underlying principle of cosmic organization that we have yet to discover. An elegant and powerful alternative to the geometric tapestry of string theory is found in loop quantum gravity. This theory proposes that the fabric of spacetime itself is not a smooth, continuous sheet, but is fundamentally granular, composed of discrete, indivisible units called quanta of spacetime. Imagine weaving a cloth from an immense number of tiny interlocking loops. In this view, there is a smallest possible distance and a shortest possible moment of time. This inherent discreteness of reality has a profound consequence for our origin story. It forbids the existence of an infinitely dense singularity. As the universe contracts, it cannot be crushed to an infinitesimal point because there is a fundamental smallest possible volume it must occupy. The granular nature of spacetime itself provides an ultimate resistance to collapse. Loop quantum gravity therefore gives rise to one of the most compelling versions of the Big Bounce. As a prior universe collapsed under its own gravity, the density would increase to a staggering but finite degree, the Planck density. At this point, the quantum geometry of spacetime would generate an incredibly powerful repulsive force, overwhelming gravity, and forcing the universe to rebound violently. The Big Crunch would transition through a quantum bridge into a new Big Bang, the beginning of our own cosmic era. What came before our universe was a contracting mirror image of our own, a vast cosmos falling inward for eons, only to be reborn from its own hyperdense ashes through the fundamental, quantum resilience of spacetime itself. There was no beginning, only a moment of transition from one state to another. This leads us to a deeper, more foundational question. From where do the laws of physics themselves originate? Did they exist in some abstract, perfect realm before the universe began? This is a modern form of Platonism, which suggests that mathematical truths and physical laws have an independent existence outside of spacetime and matter. In this view, the equations governing gravity, quantum mechanics, and electromagnetism are not human inventions, but discoveries of a pre-existing, eternal truth. The state before the Big Bang would therefore be this realm of pure law and potential, a silent, non-physical matrix of principles awaiting a physical universe in which to manifest. The laws of nature were the silent architects, and the Big Bang was the moment they began their construction. The opposing philosophical viewpoint is that the laws of physics are not Platonic truths, but emergent properties of the universe itself. In this scenario, the laws did not exist before the Big Bang, but co-evolved with the cosmos as it expanded and cooled. In the searing, simple conditions of the earliest moment, the governing principles may have been far simpler. As the universe underwent phase transitions, breaking symmetries and giving rise to new particles and forces, the laws of physics as we know them would crystallize and emerge, much like the complex rules of biology emerge from the simpler rules of chemistry. This suggests a universe that is not just following a pre-written script, but is in some sense writing its own laws as it unfolds, making the before state a realm of pure chaos or simplicity, from which all complexity and order had to be generated. Let us reconsider the very nature of time through the lens of the block universe model suggested by Einstein's theory of relativity. This model posits that time is not a flowing river, but a fourth dimension, inextricably fused with the three dimensions of space into a static, four-dimensional block of spacetime. In this block, every event, from the Big Bang to the final extinction of the last star, exists simultaneously and eternally. The past, present, and future are all equally real, laid out in this cosmic structure. Our conscious experience of a moving now is merely an illusion, a psychological artifact of how our minds process information. The Big Bang in this view is not a moment of creation in time, but is simply one boundary of the space-time block, the past edge of a single, timeless, and complete cosmic object. If the block universe model is an accurate description of reality, then the question, what came before the Big Bang, becomes fundamentally meaningless in a new and profound way. It is akin to standing beside a great statue and asking what came before the statue's base. The base is simply the bottom of the object. There is no before to it in that context. Similarly, if the entire history of the universe is a single static object, then the Big Bang is simply the temporal boundary of that object. There is no before, because the concept of a temporal sequence only makes sense within the block, not outside of it. The universe did not happen. It simply is. Its existence is a brute, eternal fact, a complete story from beginning to end, with no preceding page. Returning to the concept of fecund universes born from black holes, let us explore the idea of a nested reality. If our universe was created by a black hole in a parent cosmos, then that parent cosmos is itself likely filled with countless other black holes, each one a potential gateway to a new baby universe. And that parent universe may have, in turn, been born from a black hole in a grandparent universe. This leads to the staggering vision of an infinite cosmic fractal, a multiverse of nested realities, branching and budding off from one another through an endless chain of stellar collapse and quantum rebirth. The state before our Big Bang was simply the interior of a star in another reality, a link in a generational chain of cosmic creation that stretches back not through our own timeline but through an infinitely layered higher dimensional history. An alternative way to conceptualize the multiverse is through the causal patch model. The universe created in the Big Bang may be vastly larger than what we can observe, perhaps even infinitely large. Our observable universe, the sphere of space from which light has had time to reach us, is just one patch in this immense fabric. Beyond our cosmic horizon, there are other patches, other domains of space, so distant that we will never be able to see them or interact with them. They are causally disconnected from us. In this picture, the Big Bang was not the beginning of a single, isolated universe, but the event that created this entire unending tapestry. The before question remains, but our own existence becomes a local story, the history of a single patch in a potentially infinite and eternal cosmic ocean. Let us pause and meditate on the character of the vacuum itself. We think of space as emptiness, a void separating worlds. But in modern physics, the vacuum is a dynamic and pivotal entity. It is the ground state of all quantum fields, simmering with latent energy and virtual particles. It is the medium through which forces propagate. Dark energy, the mysterious force accelerating the expansion of the cosmos, appears to be a property of the vacuum itself, an intrinsic energy of empty space. The state before the Big Bang, in many theories, was a different kind of vacuum, a false vacuum with a much higher energy level. The Big Bang was a phase transition of this vacuum, a cataclysmic decay into the lower energy state we inhabit today, releasing a torrent of energy that became all the matter in our universe. The nothing of the void was the ultimate something. The principle of information conservation, a cornerstone of quantum mechanics, suggests that information can never truly be destroyed. This poses a famous paradox for black holes, but it also has profound implications for the Big Bang. If our universe began from a singularity, a point of seemingly infinite information density, where did that information come from? If we are living in a universe that bounced back from a previous contraction, then perhaps the information from that prior cosmos was not erased. It may have been profoundly scrambled and compressed, but its essential content could have been preserved across the quantum bridge, encoded in the initial conditions of our own expansion. We may be living in the rearranged data of a forgotten, older world, its history forming the statistical bedrock of our own reality. It is entirely possible that the true nature of our cosmic origin is a synthesis of several of these seemingly disparate ideas. Reality may be a grand, layered structure where none of these theories holds the complete picture, but each describes a facet of the whole. Perhaps we exist in a bubble universe, one of many, in an eternally inflating multiverse, but that entire multiverse structure is itself just one cycle in an even grander big bounce. And perhaps this entire bouncing multiverse is a holographic projection of information stored on the boundary of a higher dimensional brain world. The state before our Big Bang could be a superposition of all these possibilities, a reality so complex and multifaceted that it requires a pantheon of theories to even begin to glimpse its true form. The truth may not be one story, but an entire library. Let us revisit the participatory universe of John Wheeler, one of the most radical and mind-bending interpretations of quantum mechanics applied to cosmology. It suggests that the act of observation, of asking a question about the universe's past, plays a role in bringing that past into concrete reality. An unobserved quantum system exists in a superposition of all possible states. By observing the cosmos now, we force a specific history to be selected from this cloud of possibilities, all the way back to the earliest moments. In this view, the universe before it was observed by conscious beings was an unrealized dream of potential. The state before the Big Bang was a state of pure quantum indeterminacy, and our own existence as observers is what retroactively solidifies the chain of events that led to us. What are the philosophical consequences of a universe with no ultimate beginning? For millennia, creation stories have provided a foundation for meaning, purpose, and morality, rooting them in a singular act of will or creation. An eternal cosmos, whether it be cyclical or part of an infinite multiverse, removes this foundational anchor. It presents us with a reality that is uncaused, uncreated, and possibly without any inherent purpose. This can be seen not as a loss, but as a liberation. It means that meaning is not something to be received from an external source, but something that must be created from within. We are not actors in a pre-written play, but participants in an ongoing, eternal process, free to define our own significance within the grand, silent, and unjudging expanse of an infinite reality. To understand why a before is so problematic for physics, we must appreciate the nature of the singularity predicted by general relativity. It is not a tiny point sitting in an otherwise empty space. It is a moment where space itself ceases to exist. At the singularity, the curvature of space-time becomes infinite, and all distances shrink to zero. The very concepts of space, time, and location dissolve. It is a true edge of the universe, a point beyond which the equations of general relativity simply produce nonsense. Therefore, asking what came before, it is like asking for a coordinate on a map that lies beyond the map's edge. Classical physics provides no language or framework to describe such a state, forcing us into the realm of quantum gravity to seek any potential answers. Quantum gravity is the holy grail of modern physics, and its primary task is to resolve the paradox of the singularity. Both string theory and loop quantum gravity, in their own ways, smear out this infinitely sharp point. They suggest that as you approach the conditions of the Big Bang, the classical picture of a smooth space-time fabric dissolves into a roiling sea of quantum effects. The singularity is replaced by a finite, though mind-bogglingly extreme, state. It could be a Planck-scale nugget of space-time foam, or a string gas of fundamental vibrating filaments at maximum temperature. This resolution is crucial because by replacing the hard wall of the singularity with a physical, albeit bizarre, state, it opens up the possibility of a scientific description of a pre-Big Bang era, transforming the question from a philosophical paradox into a physical problem. Even within the framework of a cyclical universe, we must consider the possibility of cosmic forgetfulness. While some models like Penrose's suggest faint traces from a previous eon might survive, Other big bounce scenarios imply a near-perfect reset. The extreme conditions of the bounce could be so violent that they effectively erase all complex information from the preceding cycle. All the intricate structures, galaxies, stars, life of the previous universe would be completely thermalized, their information content reset to a state of maximum entropy. In this case, the universe would be reborn with its fundamental physical laws intact, but with no memory of its past life. The before would be a causally disconnected ancestor, a forgotten civilization whose only legacy is the raw material and the constitutional laws from which we are built. A truly remarkable and symmetrical vision for a pre-Big Bang state comes from the work of physicist Julian Barbour. He proposes that the Big Bang was not a beginning of time, but a central Janus point, named after the two-faced Roman god. From this central moment of lowest complexity, two universes expanded in opposite temporal directions. Our universe is on one side of this point, with our arrow of time pointing away from it. But there is also a mirror image anti-universe on the other side, also expanding and forming structure, but where time, from our perspective, runs backward. For inhabitants of that universe, their past is our future, and their arrow of time also points away from the common origin. What was before our universe was the shared, timeless, and chaotic origin point from which our twin reality was also born. There is a deep philosophical solace to be found in the idea of an eternal, uncaused cosmos. The burden of a singular creation event, with all its attendant paradoxes of a first cause, simply dissolves. Instead of an arbitrary beginning from an absolute nothing, we are placed within a process that has always been and will always be. This perspective can induce a profound sense of calm and belonging. Our fleeting existence is not a brief spark in an empty void between two eternities of nothingness, but a small, intricate eddy in an infinite and ever-flowing river of being. The universe was not made for us, but we are made of it, an intrinsic and natural expression of its eternal properties. We are, in the most literal sense, at home in an infinite reality. While the standard cosmological model is built upon a hot, dense Big Bang, it is worth contemplating the alternatives that have been proposed throughout history. Before the discovery of the cosmic microwave background, the steady-state theory was a serious contender. It posited an eternal, expanding universe where new matter was continuously created in the vacuum to maintain a constant density. There was no beginning, no Big Bang. Another concept is the idea of a universe emerging not from heat, but from a vast, cold, and static state, a cosmic egg, or a static Einsteinian universe that became unstable. While these ideas are not supported by current evidence, they serve as a valuable intellectual exercise, reminding us that our current understanding is a model, not the absolute truth, and that the history of science is filled with beautiful ideas that have given way to more powerful explanations. Let us explore a more teleological perspective, the idea that the universe is not just pushed from the past, but is also pulled toward a future. Thinkers like Pierre Teilhard de Chardin envisioned an omega point, a future state of maximum complexity and consciousness towards which the entire cosmos is evolving. In this view, the universe is not a random, aimless process, but has an inherent directionality. The Big Bang is the starting point of a process designed to reach this ultimate state of integration. The laws of physics are not arbitrary, but are precisely what is needed to guide this cosmic evolution. What came before the Big Bang is less important than what comes after the end of time. The entire history of the cosmos is a single, purposeful narrative, and we are living in one of its crucial chapters. Consider the idea of a multiverse, not as separate bubbles of space-time, but as different branches of a quantum wave function. The many worlds interpretation of quantum mechanics suggests that every time a quantum measurement is made, the universe splits into multiple branches, one for each possible outcome. All these parallel worlds are equally real. If we apply this to cosmology, the initial state of the universe before the Big Bang was a single quantum wave function containing all possibilities. The Big Bang was the moment this universal wave function began to decohere and branch into the myriad parallel histories that make up the quantum multiverse. We are simply following one specific path through this infinitely branching tree of realities. Before the Big Bang, all possible universes existed as one, in a state of pure, unsplit potential. This quantum multiverse model presents a reality of breathtaking scope. It means that every possibility is realized in some branch of reality. There are universes where the fundamental constants are slightly different, universes where life never evolved on Earth, and universes that are nearly identical to our own, differing only in the position of a single particle. This is not a multiverse of distant, inaccessible spaces, but one that is constantly being created all around us. With every quantum event, the state before the Big Bang was the seed of this infinite tree, a single point of quantum potential that contained within it the blueprint for every story that could ever possibly unfold, a truly ultimate library of all possibilities. Let's re-examine the fine-tuning of the universe from a different angle. The precise values of constants, like the cosmological constant, are so exquisitely tuned for life that it seems impossibly coincidental. While the anthropic principle in a multiverse provides one explanation, another is the idea of a self-organizing principle. Perhaps the universe has a natural tendency to evolve its parameters towards values that allow for greater complexity. Much like natural selection in biology, this could happen through a cyclical model where the constants are slightly altered with each bounce, with fertile universes being more likely to reproduce. In this view, the before state was a less complex, less finely tuned universe, and our cosmos is the product of a long evolutionary process of cosmic learning and self-improvement. This concept of a self-organizing, learning universe is deeply profound. It imbues the cosmos with a sense of dynamism and creativity. The laws are not static, but can change and adapt over immense timescales. Our universe is not just a fortunate accident, but the result of a cosmic trial and error, a process that has refined the conditions for existence over countless iterations. The era before our Big Bang was a prior, less successful experiment in cosmic creation. We are the beneficiaries of an ancient lineage of universes that have gradually discovered the right formula for creating stars, galaxies, and the potential for consciousness. It places our existence in a story of cosmic progress, a slow, patient journey toward greater complexity and awareness. The very darkness of the night sky, a phenomenon known as Olber's paradox, is a powerful piece of evidence for the Big Bang. If the universe were infinitely old, static, and uniformly filled with stars, then every line of sight would eventually end on the surface of a star, and the night sky would be as bright as the sun. The fact that it is dark tells us that the universe is not infinitely old. It has a finite age. The light from the most distant stars has not had time to reach us yet. That darkness is the shadow of the beginning. It is a silent, omnipresent reminder that our universe is a dynamic, evolving entity with a history. The before is written in that absence, in the profound and calming blackness between the distant, ancient points of light. Let us contemplate the aesthetic of simplicity. Occam's razor, the principle that the simplest explanation is often the best, can be applied to our cosmological models. Which of these ideas is the most elegant? Perhaps it is the no-boundary proposal, which eliminates the need for a before and presents the universe as a perfectly self-contained and mathematically complete entity. There is no prior cause, no multiverse, no endless cycle, just a single, timeless quantum event described by the beautiful laws of physics. Its power lies in what it removes, the messy and perhaps unanswerable question of an ultimate origin. It suggests the universe is its own reason, its existence a fundamental consequence of the logic of reality, requiring no further explanation. The state before the Big Bang was, in a sense, a logical fallacy. Conversely, one could argue that the multiverse is the more natural and less contrived explanation. To assume that the incredibly specific, life-permitting values of our universe's constants occurred only once seems like an extraordinary claim of specialness. It is perhaps more simple and more humble to assume that our universe is just one of many outcomes in a much larger, more diverse cosmic reality. The existence of our universe is not a miracle to be explained, but a statistical inevitability given an infinite number of chances. The eternal inflationary multiverse, while mind-bogglingly vast, might be the most parsimonious explanation for our own seemingly improbable existence. The state before our Big Bang was simply the normal, chaotic state of the true larger cosmos. The cosmic microwave background radiation is the most ancient light in the universe, a relic from just 380,000 years after the Big Bang. It is a baby picture of our cosmos, and its subtle temperature fluctuations are the seeds from which all galaxies and cosmic structures eventually grew. These fluctuations are thought to have originated as quantum jitters in the pre-Big Bang inflationary epoch, stretched to astronomical sizes by the universe's hyper-expansion. When we map this ancient light, we are looking at the fossilized evidence of quantum mechanics operating on a cosmic scale. We are seeing the ghost of the moment just after creation, a direct window into the physics that govern the birth of our world, bringing the before state from the realm of pure speculation to the edge of observational science. Gravitational waves, the ripples in the fabric of spacetime, offer another potential window into the pre-Big Bang era. While the cosmic microwave background shows us the universe as it was when light was first set free, primordial gravitational waves would have been generated in the very first fraction of a second of the Big Bang itself. These waves would travel through the universe completely unimpeded, carrying with them a pristine signature of the universe's birth. Detecting this primordial gravitational wave background is a major goal of modern astronomy. If found, it could allow us to test theories like eternal inflation or the Big Bounce directly, providing a sonogram of the Big Bang and potentially revealing the echoes of a universe that existed before our own. Consider the sheer amount of energy unleashed in the Big Bang. All the matter and radiation in our observable universe, equivalent to billions of trillions of suns, was once contained in a volume smaller than an atom. The source of this incredible energy density is one of the key questions any origin theory must answer. In inflationary cosmology, this energy was borrowed from the gravitational field during the hyperexpansion phase. The inflaton field acted as a mechanism to extract energy from the geometry of spacetime itself and convert it into the particles that fill our universe today. The state before the Big Bang was therefore a state of pure potential energy, locked away in a quantum field that permeated a tiny, unstable speck of spacetime. Let us meditate on the profound interconnectedness implied by a singular origin. Every particle in your body, every atom in the Earth, every star in the Milky Way galaxy, was once compressed together in that initial superhot, superdense state. We are all made of the ashes of that primordial fire. This shared origin story is the most fundamental connection we have with the cosmos. The elements forged in the hearts of stars are a continuation of that creative process, but the ultimate brotherhood of all matter was sealed in the first moments of the universe's existence. The state before the Big Bang is our ultimate common ancestral home, a place and time from which all things in our reality have descended, linking every speck of dust into one grand, unbroken cosmic story. The concept of an uncaused cause, or a prime mover, has been a central theme in philosophy for thousands of years. It is an attempt to solve the problem of infinite regress. What caused the thing that caused the thing? Modern cosmology forces us to confront this question in a scientific context. The Hartle-Hawking no-boundary proposal is one attempt to formalize this idea, presenting a universe that is its own cause, a closed causal loop. Other theories push the regress back, suggesting our universe was caused by a black hole or a brain collision, which simply begs the question of where the parent universe or the brains came from. The state before the Big Bang is the final frontier of this ancient philosophical quest, the point where the chain of causality either begins, loops back on itself, or dissolves into meaninglessness. The arrow of time, our intuitive sense that time flows from past to future, is deeply connected to the second law of thermodynamics, which states that entropy, or disorder, always increases in a closed system. The universe began in a state of incredibly low entropy, a highly ordered state, and has been becoming more disordered ever since. This is why we can remember the past, a lower entropy state, but not the future, a higher entropy state. A key mystery is why the universe started in this special, low entropy condition. Perhaps the before state was one of maximum entropy, a chaotic thermal equilibrium, and our universe is just a rare statistical fluctuation into a more ordered state, a temporary island of decreasing entropy in an eternal sea of chaos. This thermodynamic perspective offers a haunting vision. If our ordered universe is just a temporary fluctuation, then the natural state of reality is complete disorder. The structures we see, the galaxies, the stars, life itself, are beautiful but fleeting aberrations. The ultimate fate of the universe is to return to this high entropy state of heat death, where all structure is erased. In a cyclical model, the bounce mechanism would have to somehow reset the entropy with each cycle, a major theoretical challenge. The state before the Big Bang, therefore, holds the key to understanding the very nature of time's arrow. It was either the ultimate point of perfect order, or it was a chaotic sea from which our ordered bubble just happened to emerge. Let us close our eyes, metaphorically, and listen. The universe is not silent. It is filled with a faint hiss of radio waves, the cosmic microwave background. This is the oldest sound, the echo of creation. It is the sound of the universe when it was a hot, dense fog, 380,000 years after the beginning. It is uniform in all directions, a testament to a shared origin. To listen to this signal with a radio telescope is to listen to the past, to connect directly with the remnant heat of the Big Bang. Contemplating this ancient, omnipresent hum is a powerful meditative practice. It is the sound of our cosmic womb, a reminder that the seemingly cold, dark void is filled with the warmth of our own birth. What if our universe is not unique, but common? The principle of mediocrity suggests that we should assume we are not in a special position in the cosmos. If our universe exists, it's likely that the conditions that created it are not unique, and that countless other universes have been created by similar means. This is a powerful argument for the multiverse. It reframes our existence from a singular miracle to a common occurrence. The state before our Big Bang was not a special, one-off event, but a generic process of universe formation, one that has likely played out an infinite number of times. Our grand cosmos is just one tree in an infinite forest, a single grain of sand on an endless shore, a beautiful but ultimately unremarkable example of reality's generative power. Let us revisit the idea of our universe as a simulation. If this is the case, then the Big Bang was simply the moment the program was run, the boot sequence for our reality. The laws of physics are the lines of code. The state before the Big Bang would be the state of the computer before our program was initiated. It could have been running other simulations, other universes, or it could have been idle. This hypothesis is perhaps impossible to test, but it is a powerful philosophical tool. It forces us to distinguish between ontological reality, the computer, and phenomenological reality, our simulated world. The ultimate origin of our existence would not be found in the physics of our universe, but in the nature of the reality that contains it. The simulation hypothesis raises questions about the resolution of our reality. Just as a video game has a smallest pixel, our universe appears to have a smallest scale, the Planck length. Is this a sign that our space-time is a digital construct? Physicists are actually looking for evidence of this, such as tiny variations in the speed of light for different colors, which could indicate a pixelated space-time. If such evidence were found, it would be a profound revelation about the nature of reality. The before state would be the underlying computational grid, the silent, inactive processing substrate from which the illusion of our continuous analog world is generated at every moment. Consider the mystery of dark matter, the invisible substance that makes up about 85% of the matter in the universe. We can only detect its gravitational influence holding galaxies together. What if dark matter is a clue about the pre-Big Bang state? Perhaps it is matter from a parallel brain world, a universe that overlaps with our own in higher dimensions. We cannot see it or touch it, because it exists on a different membrane, but we can feel its gravity, which is the one force that can leak across the bulk. In this scenario, the starry sky we see is only half the story. We are coexisting with a shadow cosmos, a silent partner in our cosmic dance, and the state before the Big Bang was the moment these two realities were either created together or collided. This idea of a shadow universe, detectable only by its gravity, adds a layer of unseen depth and mystery to the cosmos. Every galaxy we observe is cradled in a vast, invisible halo of this dark matter. The structure of our universe, the great cosmic web of galactic filaments and voids, is primarily shaped by its gravitational scaffolding. So in a very real sense, the visible world is just the decoration on a much larger, invisible reality. Contemplating this is to recognize the limits of our own perception. The universe is far grander and stranger than what our eyes can see, and the state before our universe's birth may have established the rules for both the luminous world we inhabit and the dark world that silently governs it. Let us return to the final, quiet moment of reflection. All of these theories, from the scientifically rigorous to the wildly speculative, are products of the human mind. They are stories we tell ourselves to make sense of the ultimate question of existence. They are woven from the threads of mathematics, observation, and imagination. The calm we seek is not in finding the one true story, but in the appreciation of the mind's ability to create such a rich and diverse tapestry of possibilities. The universe does not speak to us in human language, so we must invent languages of physics, of philosophy, of myth, to speak of it. The state before the Big Bang is the ultimate silence, and these theories are our attempt to fill that silence with meaning, beauty, and wonder. The feeling of the sublime is the experience of being overwhelmed by something vast, powerful, and beyond our full comprehension, yet feeling a sense of exaltation rather than fear. This is the psychological state we have been cultivating. The cyclical universe, with its infinite timescale, is sublime. The multiverse, with its infinite variety, is sublime. The mathematical elegance of the no-boundary proposal is sublime. To contemplate the state before the Big Bang is to stand at the edge of the ultimate sublime object, reality itself. It is to let go of the need for simple answers, and to allow the mind to be stretched to its absolute limits, finding peace not in certainty, but in the sheer, awe-inspiring scale of the mystery. Let us consider the role of pure chance. In many of these models, particularly those rooted in quantum mechanics, our universe is the result of a random event, a quantum fluctuation, a bubble nucleation, a random tunneling between vacuum states. This replaces a universe of deterministic cause and effect with one of fundamental probability. Our existence is not a necessity, but the outcome of a cosmic lottery. This can be a deeply humbling perspective. It removes any sense of cosmic specialness or destiny, and instead presents our reality as a fortunate accident. The state before the Big Bang was a sea of probability, a realm of maybes, and our universe is just one of those possibilities that happen to become actual. This probabilistic origin has profound implications. If the process is truly random, then it is likely that it has happened before and will happen again. A universe born from a quantum fluctuation is likely one of an infinite ensemble of such universes. So the idea of chance does not lead to a lonely, singular cosmos, but paradoxically points back towards the multiverse. It suggests that the underlying fabric of reality is inherently generative and unstable, always bubbling with the potential to spawn new worlds. The state before our Big Bang was not a tranquil nothingness, but a chaotic, probabilistic engine of creation, relentlessly rolling the cosmic dice, with each outcome giving birth to a new and unique cosmos. As we draw this exploration to a close, let the intellectual details of each theory begin to fade. Allow the dense river of information to slow and settle. What remains is not a set of facts to be memorized, but a feeling, an atmosphere. It is the feeling of standing on a quiet shore at night, looking out over a vast, dark ocean, and knowing that the depths hold mysteries you can never fully plumb. You do not need to know what lies beneath every wave to appreciate the majesty of the ocean. In the same way, you do not need to know what came before the Big Bang to feel a profound sense of connection to the majesty of the cosmos. The journey we have taken is from a simple question to a complex landscape of possibilities. We have seen how science pushes the boundaries of knowledge, transforming philosophical questions into testable hypotheses. We have also seen where those boundaries currently lie, the point where science must hand the baton to speculative thought and quiet contemplation. This boundary is not a place of failure, but a place of immense creative and intellectual fertility. It is the space where new ideas are born, where our sense of wonder is kindled, and where the human mind finds its most expansive and peaceful state, poised between the known and the profoundly, beautifully unknown. Let the final thought be one of unity. All of these origin stories, in their own way, point to a common source. Whether it was a singularity, a quantum foam, a previous universe, or a higher dimension, everything in our known reality, every star, every planet, every living being, emerged from the same crucible. We are all cut from the same cosmic cloth, born from the same primordial event. This shared heritage is the ultimate truth that lies beneath all the complex physics and abstract philosophy. It is a simple, powerful, and deeply calming realization. Our connection to the cosmos is not an abstract idea, it is a physical fact, written into every particle of our being. The night sky is a time machine. The farther we look, the deeper we peer into the past. But it is also a mirror. In asking what came before the Big Bang, we are also asking about ourselves. What is the origin of the consciousness that asks the question? What is the nature of the mind that can conceive of such cosmic scales? The quest for the universe's origin is inextricably linked to the quest for self-understanding. As we project our intellect outward to the edges of space-time, we are also plumbing the innermost depths of our own awareness, finding in the cosmic mystery a reflection of the mystery within. And so, we rest. We let the grand cosmic narratives dissolve into the quiet darkness. The intellectual journey is complete, and what is left is a state of serene wonder. The need for an answer fades, replaced by a comfortable and peaceful acceptance of the mystery. The universe will continue its silent, majestic dance, and the ultimate question of its origin will remain, not as a frustrating puzzle, but as a timeless, cosmic koan, a source of infinite contemplation. It is the final, gentle hum beneath the noise of the world, a deep and resonant chord that connects the quiet of your mind to the silent eternity of space. The state before the beginning remains the ultimate unknown, a realm beyond the reach of our telescopes and perhaps even our theories. It is a canvas onto which we project our most profound ideas about time, existence, and creation. Whether it was a contracting cosmos, a sea of quantum foam, a higher dimensional collision, or a state for which we have no name, its legacy is the magnificent, star-strewn universe we inhabit. To fall asleep with this question in mind is to drift off into the grandest of all mysteries, allowing the mind to let go of the everyday and merge with the silent, eternal, and awe-inspiring fabric of the cosmos. Let us now venture into the most abstract of all possible landscapes, the realm of pure mathematics. The mathematical universe hypothesis, proposed by physicist Max Tegmark, presents a radical and breathtakingly simple idea that our physical universe is not merely described by mathematics, but that it is a mathematical structure. In this view, there is no distinction between the elegant equations that govern reality and reality itself. All of existence is a vast, timeless mathematical object, and we are self-aware substructures within it. The state before the Big Bang, therefore, was not a physical state of being, but the eternal, unmanifested realm of all possible mathematical structures, existing platonically, outside of time and space. Our universe is but one of these structures, complex enough to contain self-aware parts that can perceive it as a physical world. If this mathematical universe hypothesis holds true, then every logically consistent mathematical structure corresponds to a physically real universe. This is perhaps the ultimate multiverse theory, encompassing not just universes with different physical constants, but universes with entirely different physical laws, dimensions, and fundamental components, as long as they can be described by a consistent mathematical framework. The reason we find ourselves in this specific universe, governed by the complex rules of general relativity and quantum field theory, is a form of observation selection. Simpler mathematical structures are not complex enough to generate the information processing substructures we call consciousness. The state before our Big Bang was the entire library of mathematics, and our universe is the one book complex enough to be able to read itself. Let us re-examine the force of gravity from an entirely different perspective, not as a fundamental force, but as an emergent phenomenon, akin to temperature or pressure. This is the paradigm of emergent gravity, which suggests that space-time is like a fluid, and gravity is simply a macroscopic manifestation of the thermodynamics of its microscopic, unseen constituents, the atoms of space-time. In this view, Einstein's equations are not fundamental laws, but are analogous to the laws of fluid dynamics, describing the collective behavior of these deeper components. The question of the before state is then transformed. It is no longer about the origin of space-time, but about the nature of the primordial, pre-geometric fluid of spacetime atoms, a state that likely existed without gravity or even a recognizable geometric structure. This thermodynamic view of gravity connects profoundly with the physics of black holes. The famous discovery that a black hole's entropy is proportional to the surface area of its event horizon was the first major clue that gravity and information are deeply intertwined. It suggests that the microscopic atoms of spacetime are related to fundamental units of information or bits. The state before the Big Bang, then, may have been a state of maximum entropy, a chaotic, featureless gas of these spacetime atoms. The Big Bang was a massive, statistically improbable fluctuation into a state of extremely low entropy, which is what created the arrow of time and allowed for the formation of all the complex structures we see today. Our entire cosmos is a temporary, ordered anomaly in an eternal sea of thermal chaos. Another attempt to describe the granular nature of space-time is found in causal set theory. This approach posits that the most fundamental aspect of reality is not distance or time, but the relationship of cause and effect. Space-time is built from discrete events, and the only information that matters is which events can influence which other events. The universe grows by the continuous accretion of new events. In this model, the before state is a state of pure acausality, a random sprinkling of disconnected events with no coherent structure of cause and effect. The Big Bang was the moment a large, ordered causal structure began to crystallize out of this primordial chaos, like a growing crystal in a disordered solution. Our reality is a vast, ever-growing crystal of causality. The profound implication of a discrete, growing space-time is that the future is not yet written. Unlike the black universe model where all of time exists at once, a causal set universe is genuinely and fundamentally becoming. The present moment is the dynamic boundary between the fixed past, the set of events that have already occurred, and the probabilistic future, the potential for new events to be born. This restores a sense of genuine flow to time. The state before the Big Bang was a state with no past, the very first moment from which the process of becoming was initiated. Our universe is not an object, but a process, an ongoing and ceaseless act of creation, with each new moment adding another fundamental atom to the fabric of reality. Let us refine the concept of cosmic evolution with the theory of cosmological natural selection. This idea, proposed by physicist Lee Smolin, suggests that universes reproduce through the creation of black holes. When a black hole forms and collapses into a singularity, it may create a new baby universe on the other side, but with its fundamental physical constants slightly altered or mutated. Universes whose constants are tuned to produce the maximum number of black holes will have the most offspring and will come to dominate the multiverse. Remarkably, the conditions needed to produce lots of black holes, long-lived stars, stable galaxies, rich carbon chemistry, are also the conditions needed for life. Our existence, then, is a byproduct of a universe that is highly optimized for its own reproduction. This evolutionary model provides a naturalistic explanation for the fine-tuning of our universe without resorting to an intelligent designer or the anthropic principle. It suggests a dynamic, learning cosmos that has arrived at its current, life-permitting state through a long process of trial and error over countless generations of parent universes. The state before our Big Bang was the interior of a black hole in a highly fit parent universe, one that had inherited a successful set of physical laws from its own ancestors. We are living in a cosmos that is not just a random occurrence, but a descendant of a long and successful lineage, a champion in a cosmic evolutionary struggle for existence that has been playing out for an eternity. Let us consider the provocative maxim of physicist John Wheeler, "It from bit." This is the hypothesis that the fundamental stuff of the universe is not matter or energy, but information. Every particle, every force, every point in space-time is ultimately built from binary distinctions, from yes or no answers to questions posed at the quantum level. The physical world, in all its solidity and complexity, is an emergent property of an underlying informational reality. In this framework, the state before the Big Bang was a state of pure, unstructured potential information, a sea of qubits in a timeless superposition. The Big Bang was the first act of measurement, the first bit of information that cascaded into the complex algorithm that is our unfolding cosmic history. The it-from-bit hypothesis elevates the role of the observer to a cosmic level. If reality is fundamentally informational, then systems that process information, conscious minds, are not accidental byproducts of the universe, but are intrinsically linked to its very being. The act of observation, of a conscious system registering a bit of information, is what transforms potential into actual. The universe may grow and become more real as the amount of consciousness within it increases. The state before the Big Bang was a universe of unmanifested potential, and our own collective consciousness, along with any other conscious life, is participating in the ongoing act of creating the cosmos by observing it, turning the dream of potential information into the solid reality we experience. Returning to the higher dimensions of M-theory, imagine our universe as one of two parallel membranes, or branes, separated by a microscopic gap. In the ekpyrotic model, these branes are not static, but are drawn together by a force, leading to a slow, gentle collision. This collision is not a violent point-like event, but occurs across the entire infinite expanse of the branes at once, releasing a uniform burst of energy that smoothly resets the universe and initiates a hot, expanding phase, our Big Bang. After the collision, the branes bounce apart and slowly cool, eventually beginning the cycle anew over trillions of years. The before state was this cold, dark, and nearly empty phase of separation, a long cosmic winter before the fiery rebirth of a new cosmic spring. The physics that describes these speculative pre-Big Bang scenarios operates at the Planck scale, an energy frontier so extreme that it lies far beyond our current technological grasp. The Planck energy is roughly a quadrillion times greater than the energy achieved in the Large Hadron Collider. At this scale, gravity is expected to become as strong as the other fundamental forces, and the very fabric of space-time is thought to break down into a quantum foam. This means that the state before the Big Bang, the true origin of our universe, is a realm governed by a set of physical laws that we have not yet discovered. Our theories are extrapolations, beautiful and intricate mathematical poems about a reality that we may never be able to directly witness, forcing us to rely on faint, indirect cosmological clues. Within the vast landscape of possibilities predicted by string theory, it is now believed that most of these 10 to the power of 500 potential universes are not mathematically stable. They belong to a swampland of inconsistent theories. It seems that creating a universe like ours, with a stable vacuum, a classical spacetime, and the right particle content, is incredibly difficult. This suggests there may be a deeper, unknown principle that sorts the viable universes from the swampland. The state before our Big Bang could be seen as a journey through this swampland, a chaotic process of reality attempting to find a stable configuration. Our universe is a rare and precious island of mathematical consistency in a vast, swampy ocean of impossible and stillborn realities. Let us question the very existence of time. Many physicists believe that time is not a fundamental aspect of reality, but an emergent property that arises from a deeper, timeless layer of existence. The equations of quantum gravity, for example, often do not contain a time variable. In this view, the universe is a static reality, and the flow of time we perceive is a result of our specific, limited perspective within it. The before state of the Big Bang, therefore, would be this fundamental, timeless reality itself. The Big Bang is not an event that happened in the distant past. It is a permanent feature of this timeless structure, and our perception of it as a beginning is an artifact of our consciousness, which can only process this static reality one moment at a time. Quantum entanglement, which Einstein called spooky action at a distance, reveals a deep non-locality in the universe. Two particles, once linked, can be separated by billions of light years, and a measurement of one will instantly influence the state of the other. Some theories propose that the entire universe is a single, highly entangled quantum object. The state before the Big Bang, the initial singularity, was a state of perfect entanglement, where every part of the universe was one and the same. The expansion of the universe has stretched these quantum connections across vast cosmic distances, creating the illusion of a reality made of separate, isolated objects. But beneath this illusion lies a deep, unbroken wholeness, a silent, invisible web connecting every particle to every other particle, and all of it back to the single, unified state of origin. The stability of our universe's vacuum is not guaranteed. According to particle physics, our Higgs field may exist in a metastable or false vacuum state. A random quantum fluctuation could, at any moment, trigger a decay to a lower energy, true vacuum. This would create an expanding bubble of pure destruction, traveling at the speed of light, altering the laws of physics and wiping the universe clean. But this terrifying end could also be a creative beginning. Perhaps our own Big Bang was precisely this kind of vacuum decay event in a higher-energy parent universe. The state before our Big Bang was another cosmos, with its own stars and galaxies and perhaps even life, that was suddenly and completely annihilated to provide the energy for our own existence. We may be living in the aftermath of a cosmic catastrophe. In the ongoing quest for a theory of everything, physicists have recently uncovered a new mathematical object called the amplituhedron. This geometric shape provides a remarkably efficient way to calculate particle interactions, suggesting that our familiar concepts of space-time locality, that causes must precede effects, and quantum unitarity, that probabilities must add up to 1, are not fundamental principles. Instead, they appear to emerge as consequences of this deeper, timeless geometric structure. This hints at a reality where the before state was not a physical process unfolding in time, but a pure, abstract geometry. The Big Bang and the entire history of the universe could be nothing more than the properties of this beautiful, eternal mathematical jewel, which we only perceive as a temporal story. We must distinguish between the nothing of the physicist, the quantum vacuum, a structured void seething with potential, and the nothing of the philosopher, absolute non-being. Physics can plausibly describe a universe arising from the physicist's nothing, but it cannot address the ultimate question of why there is something rather than absolute nothing. Why is there a quantum vacuum? Why are there laws of physics? Why is there existence at all? This question marks the hard boundary of science and philosophy. To contemplate it is to stand at the precipice of reason itself. The state before the Big Bang, in this ultimate sense, is the state of non-existence. And the true miracle is not the specific form of our universe, but the simple, brute fact that there is a universe at all. The philosophy of panpsychism offers a radical alternative to the conventional view of consciousness. Instead of seeing it as a rare and complex phenomenon that arises only in biological brains, panpsychism posits that consciousness, in some rudimentary form, is a fundamental and ubiquitous property of all matter. Every electron, every quark, possesses a simple, primitive form of experience. In this framework, the state before the Big Bang was not a mindless, chaotic soup of energy. It was a state of primordial, unified, and undifferentiated cosmic consciousness. The evolution of the universe is the story of this cosmic mind structuring and complexifying itself, eventually giving rise to localized centers of high-level awareness, like us, who can reflect upon our own source. Our minds are not separate from the universe. We are the universe thinking. Classical physics is built on the idea of prior causes. Things are pushed from the past into the future. But what if there is also a, quote, final cause, a pull from the future? This is the concept of teleology. While dismissed by most scientists, the extreme fine-tuning of the universe for complexity and life makes it a tempting philosophical path. Perhaps there is a fundamental principle in nature that biases the evolution of the cosmos towards states of higher complexity and consciousness. This would not be an intelligent designer, but an inherent purposefulness woven into the fabric of physical law. The state before the Big Bang was then not a random fluctuation, but the necessary starting point of a cosmos destined to awaken and become aware of itself. Our existence is not an accident, but the goal towards which the universe has been striving. Consider the nature of physical constants. We call them constants, but are they truly unchanging? Some theories propose that these fundamental values, the speed of light, the strength of gravity, could have been different in the early universe, or could even be changing slowly over cosmic time. If this were true, it would revolutionize our understanding of cosmic history. The state before the Big Bang could have been a realm of completely different physics, governed by a different set of constants. The Big Bang might have been a moment when these values were frozen into place for our cosmic eon. We are living in one specific physical epoch, and the before state was a previous epoch with a different natural order, a forgotten age with alien laws of nature. The concept of a superdeterministic universe presents the most rigid and challenging view of reality. It goes beyond simple determinism, suggesting that not only is the future set by the past, but that the initial conditions of the universe and the laws of quantum mechanics are deeply correlated in a way that eliminates all randomness and even free will for experimenters. The strange results of quantum mechanics are not due to inherent probability, but because the universe is a single, indivisible block of space-time, where every event, including our own thoughts and experiments, was encoded from the very beginning. In this view, the before state is a misnomer. The Big Bang was simply the first frame of a cosmic film, where every single subsequent frame was already written, an immense and intricate clockwork with no room for chance. One of the greatest unsolved puzzles in cosmology is the measure problem in eternal inflation. If the multiverse is constantly spawning an infinite number of bubble universes, how can we make any meaningful predictions? In an infinite set, anything that can happen will happen an infinite number of times. This makes it impossible to calculate the probability of observing our specific universe. Physicists are searching for a measure, a way to regulate this infinity and restore predictive power. The solution to this problem may hold the key to understanding the nature of the multiverse. The state before our Big Bang was the chaotic infinite inflationary sea, and our universe's properties may be determined by the as-yet unknown mathematical principle that governs this infinity. Let us explore the concept of cosmic death and rebirth from a new perspective, the information paradox of black holes. Quantum mechanics insists that information cannot be lost, but general relativity predicts it is destroyed inside a black hole. The solution may be that the information is stored on the event horizon and slowly leaked back out as Hawking radiation. If the entire universe undergoes a big crunch and bounces, a similar paradox arises. How is the information of an entire cosmos preserved through the singularity? The physics of the bounce must be a form of quantum computation on a cosmic scale, a process that perfectly scrambles and then reconstructs the universe's information. The before state was a prior cosmos, its data perfectly encoded, compressed, and then re-expressed to become our own world. What if gravity is the weakest of the forces for a reason? In brain world scenarios, this is explained by the fact that gravity is the only force that is not confined to our three-dimensional brain. It leaks out into the higher dimensional bulk, and we only feel its diluted effects. This opens up a strange possibility. The before state could have been a higher dimensional reality, where gravity was just as strong as the other forces. The Big Bang could have been an event that trapped most of the fundamental forces on our brain, while allowing gravity to continue roaming the full extent of the higher dimensional space. Our universe, with its weak gravity that allows stars to burn for billions of years, is a stable haven made possible by the escape of gravity into a hidden, larger reality. Consider the universe as a work of art. The laws of physics display a profound and unexpected beauty, a mathematical elegance that physicists often describe as a primary guide in their search for truth. Why should a universe that is a product of random chance be so beautiful? Perhaps this beauty is a clue. Perhaps the fundamental principle of reality is not just logical consistency, but aesthetic harmony. The state before the Big Bang could have been a chaotic sea of possibilities, but with an underlying drive towards elegance and symmetry. The universe we inhabit is not just a random outcome, but a particularly beautiful and harmonious one, selected from the palette of possibilities by a cosmic aesthetic principle. Our appreciation of beauty would be a faint echo of this fundamental creative force. Let's re-examine the arrow of time from a psychological perspective. Our minds are built to perceive a sequence of events, to create narratives of cause and effect. We impose a temporal order on the world because that is how our brains process information and construct a coherent reality. What if this is the only place the flow of time truly exists? The fundamental physical reality could be the static block universe, and the arrow of time is a feature of consciousness, not of the cosmos. The question, what came before the Big Bang, is then a projection of our own mental architecture onto a reality that has no such structure. The universe does not have a before. Our story of the universe does. The mystery lies not in the cosmos, but in the nature of the mind that perceives it. Another approach to quantum gravity is called causal dynamical triangulation. This method models spacetime as being built from tiny, identical triangular building blocks, governed by the rules of quantum mechanics. As the computer simulation runs, these blocks spontaneously self-organize, and what emerges on a large scale is a familiar, four-dimensional universe with properties remarkably similar to our own, including a Big Bang-like origin. In this model, the before state is a chaotic, primordial phase where the building blocks are randomly connected and there are no well-defined dimensions. The Big Bang is a phase transition, like the moment steam condenses into water, where a stable, geometric spacetime crystallizes out of this quantum chaos. Our reality is an emergent structure, self-organized from fundamental, random bits of geometry. We are beings of the middle scale. Our intuition is forged in a world of medium-sized objects moving at medium speeds. But the fundamental nature of reality, both at the quantum level and the cosmological level, is deeply alien to this intuition. To contemplate the before state, we must be willing to let go of our most cherished common-sense notions, that time flows, that space is empty, that an effect must follow its cause, that something cannot come from nothing. Each of these ideas is challenged by modern physics. The state of meditative calm we are cultivating comes from this act of letting go, of surrendering our intuitive biases and allowing the mind to float freely in the strange, beautiful, and paradoxical ocean of cosmic possibilities, unburdened by the need for a simple, familiar answer. The Copernican principle states that we do not occupy a privileged position in the universe. We are not at the center of the solar system, nor the galaxy, nor the cosmos. Pushing this principle to its logical extreme suggests that our universe itself should not be considered privileged. If a physical process created our universe, it is most likely that this process has created, and is creating, other universes as well. This is a philosophical argument for the multiverse. It suggests that a single one-off universe is an unscientific and anthropocentric idea. The state before our Big Bang was simply the normal, universe-generating state of the greater reality. Our existence is not a special creation, but a typical example of the cosmos's endless fertility, a testament to the fact that we are part of something much, much larger than ourselves. Let us imagine a universe whose fundamental component is not a particle or a string, but a moment of experience. This is the philosophy of process metaphysics, which suggests that reality is not made of things, but of events or actual occasions. Each occasion is a flicker of becoming, a process of feeling the past and creating a new present. In this view, the universe is a living, growing web of interconnected experiences. The state before the Big Bang would be a state of pure, unstructured potential for experience. The Big Bang itself was the first actual occasion, a primordial flicker of becoming that initiated the cascade of events that is cosmic history. Our own consciousness is a highly complex, localized stream of these universal moments of experience. The idea of a cold Big Bang offers a radical alternative to the standard hot, dense model. Some theories propose that the universe began in a near absolute zero, empty and static state. The Big Bang was then a phase transition, not from heat, but from this state of extreme cold and order, which triggered the rapid expansion and generation of matter and energy. This would solve some theoretical problems with the standard model, such as the initial low-entropy state. The before era in this scenario was a silent, frozen, and eternal crystal of a universe, a state of perfect order. Our hot, chaotic, and dynamic cosmos is the result of the shattering of this primordial ice, a long, slow journey from perfect order into the vibrant warmth of increasing disorder. What if the universe is fundamentally relational? This philosophical stance, championed by thinkers like Leibniz, argues that space and time are not absolute containers. They are merely a description of the relationships between objects. Without objects, there is no space. Without events, there is no time. In this view, it is meaningless to ask what the universe is expanding into, or what existed before the first event. The universe is a self-contained network of relations. The state before the Big Bang was a state with no objects or events, and therefore no space or time. It was a state of true nothingness from which the first relationship, the first event, brought the entire relational structure of space-time into existence simultaneously. Let's consider the scale of cosmic voids. The vast, empty regions between filaments of galaxies are the largest structures in the universe. They are a crucial part of our cosmic story. In many models, our universe may have been born from such a void in a parent universe. A quantum fluctuation in the deep emptiness of a cosmic void could be the seed for an inflationary expansion that creates a new baby universe, causally disconnected from its parent. The state before our Big Bang was therefore not a dramatic crunch or a fiery singularity, but the deepest, darkest, quietest, and loneliest place in another world. The silent, cold emptiness of intergalactic space, a place where nothing happens for eons, until suddenly everything does. The mystery of the matter-antimatter asymmetry is a deep clue about the early universe. The laws of physics suggest matter and antimatter should have been created in equal amounts and would have annihilated each other, leaving a universe of pure light. The fact that we exist means there was a tiny imbalance, about one extra particle of matter for every billion particle-antiparticle pairs. Whatever process caused this slight preference for matter must have occurred in the first moments after the Big Bang. The before state may have been perfectly symmetric, and the Big Bang was a symmetry-breaking event that not only separated the forces of nature, but also imprinted a fundamental, life-permitting bias onto the very substance of reality, creating the material world from a near-perfect equilibrium. The very act of questioning our origins may be a fundamental feature of a life-permitting universe. A cosmos that is complex enough to create self-aware beings is also a cosmos that is complex enough to contain clues about its own history. The cosmic microwave background, the abundance of light elements, the expansion of the galaxies, these are not accidental features. They are the logical consequences of a Big Bang origin. Perhaps there is a principle of discoverability, which suggests that the laws of nature are not just life-permitting, but also comprehensible to the minds that life produces. The state before the Big Bang set in motion a story that was not only habitable, but also knowable, a puzzle designed to be solved by its own inhabitants. Let us return to the image of the cosmic horizon, the boundary of our observable universe. As time goes on, the light from more distant galaxies will have had time to reach us, and our horizon will expand. However, the accelerating expansion of the universe is pushing galaxies away from us faster than the speed of light. This means that, over trillions of years, galaxies will start to disappear beyond our horizon, one by one. Eventually, our descendants will look out into a sky that is completely empty, save for the stars of our own local group. They will have no evidence of the Big Bang, no way of knowing the true scale and history of the cosmos. We are living in a special, privileged moment, a cosmic golden age, where the universe's story is written across the sky for us to read. This vision of a future, empty sky lends a sense of urgency and preciousness to our current cosmic view. It also leads to a profound thought experiment. If we exist in a multiverse, perhaps other bubble universes are not so fortunate. Perhaps their physical laws do not allow for the kind of clear cosmic evidence we enjoy. They might be born into an eternal fog, or a reality where the evidence of the origin is immediately erased. We are the universe's lucky children, born at the right time and in the right place to piece together the grand narrative. The state before our Big Bang not only created a habitable cosmos, but also a transparent one, a universe that invites us to understand it, a mystery that offers its own clues. The search for a theory of everything is ultimately a search for simplicity, for the single, elegant principle from which all the complexity of the world emerges. Is it a vibrating string, a loop of space-time, a geometric object, a mathematical truth, or something we haven't even conceived of yet? The answer, if it is ever found, will be the ultimate description of the before state. It will be the most compressed and potent statement about the nature of reality. It will not just describe the origin of the universe, but the reason why the universe is the way it is. The quest is a testament to the human spirit's belief that reality, in its deepest heart, is not a chaotic mess, but a thing of profound, simple, and accessible beauty. Let us conclude this deluge of ideas by returning to the feeling of awe. Awe is an experience of perceived vastness that challenges our understanding of the world. We have journeyed through vast theories, vast timescales, and vast philosophical implications. The purpose was not to find a single answer, but to cultivate this state of awe, to overwhelm the analytical mind so that a deeper, more intuitive sense of wonder can emerge. This state is both intellectually stimulating and deeply calming. It is the feeling of the small self dissolving into the vastness of the cosmic mystery, finding a profound sense of peace not in knowing, but in the embrace of the magnificent unknown. What if the universe is fundamentally cyclical, but not in a way that repeats perfectly? Each cycle could be slightly different, inheriting some information from the previous eon but also subject to new quantum fluctuations. This would make the universe less like a perfect clock and more like a living organism, with each life cycle being unique. The state before our Big Bang was a previous cosmic generation, with its own history, its own stars and galaxies. A universe that lived and died to give birth to our own. We are not just a repetition of the past, but a new chapter in an epic, cosmic story that is constantly rewriting itself. A story of lineage and inheritance on the grandest possible scale. The pressure and temperature of the primordial universe were so extreme that they cannot be replicated on Earth. In those first moments, the universe was the ultimate particle accelerator, a crucible where the fundamental laws of nature were laid bare. The particles that exist today are the low-energy, frozen remnants of that initial, unified state. By studying exotic particles and pushing the limits of our technology, we are attempting to recreate tiny, fleeting echoes of that primordial fire, to glimpse the physics that governed the before state. Cosmology and particle physics are two sides of the same coin, one looking outward to the grandest scales, the other inward to the smallest, both searching for the same secret, the single unified theory that describes the moment of creation. Let us consider the silence of the cosmos. The Fermi paradox asks, if the universe is so vast and old, why have we not encountered evidence of other intelligent civilizations? One possible and sobering answer is that we are the first. Perhaps the conditions for intelligent life are so rare, the evolutionary path so fraught with peril, that we are the first species in our galaxy, or even our observable universe, to reach a stage of self-awareness. If this is true, it imbues our existence with a profound and heavy responsibility. We are the universe's first attempt to know itself. The state before the Big Bang was a mindless, unwitnessed reality, and we are the first flicker of true understanding in a vast and ancient darkness. Conversely, perhaps the universe is teeming with life, but the distances are simply too vast, or advanced civilizations choose to remain silent, or they exist in forms we cannot comprehend. This possibility is equally awe-inspiring. It suggests that the cosmos is a far richer and more interesting place than it appears. The state before the Big Bang would have then set the stage not just for one story of life, but for millions or billions of them, unfolding on countless worlds across the galaxies. We are part of a vast, unseen cosmic community, a single voice in a choir that is spread across space-time, all of us born from the same primordial event, and all of us looking up at our own skies, asking the same fundamental question about our origin. The very atoms in your body are ancient. The hydrogen is primordial, created in the Big Bang itself. The heavier elements, like the carbon, oxygen, and iron, were forged in the hearts of stars that lived and died billions of years ago. We are literally made of stardust. This is a scientific fact, but it is also a profound, poetic truth. It connects our fragile, fleeting lives directly to the grand cosmic narrative. To contemplate this is to realize that the universe is not something out there, separate from us. We are a part of the universe that has woken up. The state before the Big Bang is not a foreign country. It is our ultimate ancestral home, and its legacy is written in our very flesh and bones. The nature of reality may be that the question of a before is a category error. Imagine trying to describe the color of the number 3. The question is ill-posed because the concepts do not apply to each other. It may be that the concept of a temporal sequence of before and after simply does not apply to the universe as a whole. Time is a property within the universe. The universe itself is not in time, it is the generator of time. Therefore, the state before the Big Bang is not a moment in the past, but a timeless logical ground of being. It is the why of the universe, not the whence, a question that pushes us from the realm of physics into pure metaphysics. Let's consider a final, deeply meditative thought. The universe does not need an explanation, at least not one that would satisfy a human mind. Our desire for a story of origin, for a cause and effect narrative, is a product of our evolutionary psychology. We see agency and purpose everywhere because it was a useful survival trait. But the universe itself may be under no obligation to be comprehensible to us. Its existence could be a simple brute fact, without a reason, without a cause, without a before. The ultimate act of intellectual humility, and perhaps the key to a profound calm, is to accept this possibility, that the greatest mystery may have no solution, and that the universe simply is, in all its silent, beautiful, and inexplicable majesty. As our journey through the intellectual cosmos comes to an end, allow the myriad theories to settle and merge. The Big Bounce, the multiverse, the hologram, the simulation, the timeless block, the eternal mathematical structure, let them cease to be competing ideas and instead become facets of a single, brilliant jewel of human imagination. They are the testament to our species' relentless and courageous desire to know, to push our understanding to the very edge of existence. The beauty is not in any single theory, but in the entire collection, in the awesome power of the human mind to grapple with a question so profound that it defines the boundary of thought itself. We are left in a state of profound and peaceful ambiguity. We have no single, definitive answer to the question of what came before the Big Bang, and perhaps we never will. But we have something more valuable, an enriched and expanded sense of possibility. We have a deeper appreciation for the scale, the strangeness, and the elegance of the cosmos. We have replaced a simple, unexamined notion of a beginning with a rich tapestry of profound and beautiful ideas. This is the true gift of cosmic philosophy. It does not give us the comfort of certainty, but the sublime and expansive freedom of wonder, a state of mind that is both intellectually alive and meditatively still. And so as you drift towards sleep, let the question gently dissolve. The intellectual effort is done. The mind can now rest. Let the final awareness be not of a puzzle to be solved, but of a vast, silent, and benevolent mystery in which we are privileged to exist. The darkness of the night is not an emptiness, but a fullness, a canvas of pure potential, the same potential from which our entire cosmos emerged. By closing your eyes, you are returning to a state of quiet contemplation, a personal darkness that mirrors the great cosmic darkness, the ultimate ground of being, from which all light, all life, and all consciousness first arose.